All right, welcome everybody to another live stream. My name is Mr. Brian McLogan, and we are going to finish off our day on vectors. So this actually is not vectors on a plane. I did not change the title here. This is the dot product of vectors. Okay, so this is our day 2 of vectors, and just a reminder, we kind of get like very basic with our operations, but what we kind of covered in this lesson is we kind of talked about the unit vector. We talked about writing a vector as a linear combination as well as a magnitude and direction. Then we also worked on how to find the dot product of two vectors to help us determine if vectors were parallel, orthogonal, or neither. And then also looked into how to find, we talked about some word problems, and then we looked into finding the angle of two vectors. So hopefully we shouldn't take this live stream too long with kind of doing this front half. I'll just kind of work through those problems, and then obviously I'll check in with you guys, see if you guys have any questions. Asamaz does not seem like he is very happy to be here, so I am very sorry about that. But I see Alex Gamer, you've helped me so much. Awesome. And David, good to see you guys. Quickie, just another 17. Good to see you guys. And then what we'll do is we will add into some multiple choice kind of questions for vectors. So for any of you that are kind of also following in a pre-calculus or trigonometry classroom, and our class is kind of where you're at, we will be getting into parametric and polar equations next week. So I will plan on doing live streams on Tuesday and Thursday of next week. So parametric and polar next week. And then we'll get into a quiz coming in from there. So I think actually Wednesday, Thursday. Crap, I might actually have to go like Monday or Wednesday. So I'll try to make sure I put in the comments for you guys. So otherwise, that's where we're going to go through. So let me kind of get through this. Obviously, if you guys have some questions, we'll kind of see how this stream, kind of takes. But if you have some questions that you'd like me to answer in your own classes, I'll be more than happy to do that after I complete this homework assignment. So without any further ado, let's go ahead and get started. So the first one is, given the following vector, find the unit vector with the same direction. So just remember the unit vector here is basically, if we're going to say, here is a vector v in component form, v1 comma v2, well, then the unit vector is basically that vector v divided by its magnitude. Okay, so this is what we worked on today in class. Now this one is already labeled u, so I'm going to write the unit vector as u1. All right. Now we want to find, before we can actually figure out what the unit vector is going to be, we need to figure out what the magnitude is. So I'm going to figure out the magnitude of u, and using the formula for the magnitude, it's basically the first component squared plus the second component squared, and therefore this gives us the square root of 17. So the unit vector in this problem is going to be use of 1 is going to be the vector -4 comma 1 over the square root of 17. Now you can leave it like this, but typically, we like to actually divide that in there so we can get the vector in there. So a preferred method, at least where I like to have it written in there, would be like this. And a lot of students, some students they are trained from our last couple chapters with radicals to rationalize the denominator. There's not much of an advantage in this chapter with rationalizing the denominator, so we can just leave the radical in the denominator here. There's not many times where it comes up where that's going to benefit us. So we're just going to leave the radical as it is in the denominator. All right, for the next one, notice it is written as a linear combination. And what I told my students in this problem is, if you don't like the 3i plus 4j, like you didn't understand our lesson on the unit vectors i's and j's, then just rewrite it as a component form, 3 comma 4. All right, just stick with it from there. All right, so in this one here, that doesn't make any sense. I guess I forgot to write in there that point there. Oops. So I'll go ahead and fix that in that respect. So anyway, so I have 3i plus 4j is, going to be 3 comma 4. So again, let's go ahead and figure out the magnitude. Now notice, hopefully you guys recognize this is a Pythagorean triple. So therefore my my unit vector here is going to be the vector 3 over 4 divided by the magnitude is 5. So hopefully you recognize that the magnitude using the Pythagorean theorem here, or the formula, you're going to get 5. So let's just write the unit vector as 3 over 5, comma, 4 over 5. And I see what I was trying to do here, and I actually made a mistake, so I apologize for that. But that is incorrect. This needs to be rewritten as 2 sine of 30 degrees. So this is very similar to what we kind of did in class. In this example, though, you can see again that my magnitude has been distributed. So again, if we're looking into this, we can rewrite this vector z as 2 times the cosine of 30 degrees, comma, the sine of 30 degrees. Okay? So therefore, you can see that the magnitude of this vector, when we talked about this format, the magnitude of z is just equal to 2. So to save myself a little bit of work and space here, if you take the vector, since it's multiplied by 2, which is the magnitude, and then you divide it by 2 to find the unit vector, you can see that the unit vector is just cosine of 30 degrees, comma, sine of 30 degrees, which we could even simplify even further here, because we could definitely just rewrite this. The cosine of 30 degrees is going to be square root of 3 over 2, comma, 1/2. Right? So we could go a little bit step even further in this example because we actually know what the cosine of 30 degrees, sine of 30 degrees. And again, this makes even more sense that this is the unit vector because we know that point lies on the unit circle. And remember, the unit circle has a radius of 1. So the vector would have a magnitude of 1. So again, doing another one of those problems to really make that connection for students as far as understanding this magnitude direction form. All right, so now let's go ahead and get into the dot product. So it says find the dot product between the two vectors and then determine if the vectors are parallel, orthogonal, or neither. So really what I wanted students to do is just practice doing the dot product so they could kind of see if two vectors were, parallel or orthogonal. Obviously, we can do a lot of checking on that just by looking at the slopes of the vectors. So, but first I just want to practice using the dot product, and then from the dot product, what we will do is we'll use the slopes to also kind of verify our answer. So let's just double check here. If I had a vector u, which would be u1, u2, and I had a vector v, which is, let's say, v1, v2, then the dot product is not the multiple here, or is not multiplying them, but it's going to give us a scalar u1 v1 plus u2 v2. Okay, so that's going to give us a scalar, which is going to help us represent. And when the dot product is equal to 0, so when we have u equal to 0, we know that we have orthogonal vectors or perpendicular vectors. So the first component is u1, second component would be u2, and you can see these are all the u and v's. So if I was going to do the dot product here, I'd just do u dot v, and that's I'm just going to use parentheses, so that's -2 times -6 plus 3 times -4. And what you can see here is this gives us a positive 12 minus 12, which gives us 0. So by applying the dot product, we can see that those are orthogonal. All right. If we do the dot product again here, you can actually kind of already see, like, if I multiply these first two components and these second two components, I can immediately see that it's not going to equal the same. 2 times 6 is 12, 3 times 9 is 18. So it doesn't matter, positive or negative, it's not going to be there. But again, let's still just identify the dot product. Again, if you don't like the I and J format, then just convert it to component form, -6, 9. All right. Excuse me. So the dot product here, u dot v, is going to be -2, -6, plus 3 comma 9. Oops, what the heck am I doing? 3 comma 9, that doesn't even make any sense. 3 times 9. All right, so therefore that gives us 12. 3 times 9 is 27. So that's going to give us 39. So obviously it's not equal to 0, so they're not orthogonal. The next thing we want to do is like check to make sure to see if their slopes are the same. So you could graph both of them, but just remember if you have a vector -2 up 3, like here's my vector, I can figure out the slope by using the rise over run, using the slope triangle. I was kind of surprised. I'm not sure if they don't teach the slope triangle anymore, because I was asking my students about this and they're like, I don't remember the slope triangle. But the slope triangle is, the way to get from one point to the next point of a line. And you can easily find the slope here is 3 over -2. So if I'm comparing 3 over -2, and then I want to make sure, is that equal to 9 over -6? And obviously, if you just reduce that, you can see that they are the same. So therefore, these are parallel lines. Since they have the same slope, they're going to be parallel. So hopefully maybe you can make the determination that, hey, I bet this last example is going to be neither, which again is the case. It's not the case because it's the most complicated. Because again, if these two angles were had the same angles, right, then you obviously would know that they're parallel. Or if they were 90 degrees apart, you would know that they are perpendicular. So that's kind of like an easy way to be able to figure that out, right? However, let's still figure out the dot product on this one. So to figure out the dot product, again, for u dot v, basically I'm going to multiply that 3 cosine of 30 degrees times -2 cosine of 135 degrees, and then I'm going to add that, and I'm sorry, I'm running out of space. I'm going to have to add that. I'll do it over here. To second components, 3 sine of 30 degrees times -2 sine of 135 degrees. So that's a lot to type in the calculator, and I only have this TI-30. So make sure you're in degree mode. So let's just kind of do this one by one. So we'll do, use your parentheses will be really helpful. 3 cosine of 30, and then times -2 cosine of 135, and then plus parentheses 3 sine of 30, close, times -2 sine of 135, close. So let me make sure, just have all my parentheses. You got to be careful. Oh, so I got to do a insert parenthesis. Oh crap, I think I already made a mistake. I did. All right, so now I'm going to have to type this all over again. Jeez, oh man. So you got to be careful. 3 cosine, that's why I kind of like a TI, so it's an easier to, or like an 84, you can see your parentheses. So 3 cosine of 30, so 2 parentheses on the end, and then -2 cosine of 135, 2 parentheses, and then plus 3 sine of 30, 2 parentheses, times -2 sine 135, 2 parentheses. So assuming I typed this in my calculator correctly, the calculator definitely was doing some thinking, I am getting 1.5. Hopefully maybe somebody's following along. I didn't say what to round to, so I'm just going to round to the nearest thousandth, 1.553. And if I got it wrong, I'm going to blame it on the calculator for typing that in wrong. So hopefully in there, I just really typed this all into a calculator. The main important thing is, just make sure you're typing in those parentheses. So I'm hoping I typed it in wrong. This is not my day-to-day calculator. So just be careful with that. All right. Let's go and get on to the word problems. So the next one says a plane is approaching a runway with an angle of depression at 7 degrees at 135 miles per hour. Write a vector in terms of I and j that represent the plane's approach. Okay, so we have a plane, right? And it's approaching a runway, so that means it's going to be going up. It's in the air, and it has an angle of depression. So we're going to draw a horizontal line, and then it has an angle of depression, which is going to be 7 degrees. Right? And then it's traveling at 135 miles per hour. Okay, so write a vector in terms of I and j that represent the plane's approach. So basically, we want to write a vector from where the plane is, and then basically how it's approaching here the runway. So the angle so we have an angle of depression of 7 degrees. So there's a couple different ways we could do this. We have the angle of 7 degrees. Now, obviously, in standard form, that's going to be negative 7 degrees, right? So it's an angle of elevation of 7 degrees, but in standard form, that's negative 7 degrees. And then the vector, the magnitude of the vector is going to be 135 miles per hour. So remember, when we're given a vector for the airplane, you have the magnitude of your vector times the cosine of the angle times the sine of the angle. But again, you got to take the angle that's in standard form, because this calculator doesn't understand angles of depression or angles of elevation. It doesn't understand bearings. So you got to make sure you graph, the picture of what you have, and then insert in the angle. Insert in the angle that's going to be in standard forms, because that's what your calculator does. So in this case, again, we just need to write the vector. We don't need to do anything else. So the magnitude here is 135, and that's going to be times the cosine, cosine of negative 7 degrees times the sine of negative 7 degrees. I don't know why I'm doing that. Kind of looks weird. So we'll fix that out there. 7 degrees. Parentheses. All right. So there we go on that. So next one is actually a word problem. So plane is flying at a bearing of north 55 degrees east at 200 miles per hour. So what I told my students to do is right when you read that, let's draw it. So we're going north 55 degrees east. So probably somewhere around there. Right? And it has so that's 55 degrees. It has a magnitude of 220 miles per hour. All right, if the wind is blowing at a bearing of south 10 degrees west, crap, that's going in the other direction. So that's going to be right where I had all my writing. So let's all right, we'll just draw the vector there. So the wind is, again, here's on the, I guess I can do it from there. So the wind is, what I'll do is I'll do two vectors. So that's fine. All right. So the wind is going to be south 10 degrees west. But that's only going at 10 miles per hour. So actually, you know what? Let's put that back up there. So that's 220. And then now I'm going to be south 10 degrees west. So that is going to be 10 degrees. And that is only at 30 miles. Let me zoom in here. That's going to be at 10 degrees miles per hour. Okay? So basically, here's what we have, the situation. We have this airplane flying like this, and then you have the wind kind of come back. So the plane is going like into the wind, right? So, unless the plane is correcting, like speeding up to make sure it's going faster, or changing its course to make sure it's on course, like it's going to be shifted over. It's going to be going slower unless it corrects this wind. So what we need to do is we need to understand what is the ground. So we need to understand everything that's happening to this airplane, at least based on this word problem. And so what the question is asking is, what is the ground speed? And that basically means, like, if you were standing on the earth looking up to the plane, like, what would be the speed of the plane with the wind acting on it, and as well with the plane not counteracting, like, this movement from the wind. So to put that in another way, we're basically looking for the resultant vector of what is going to be the vector if here is my airplane, and then here is my wind. Right? Because think about it, like this is 220 miles per hour, and then this is 30 miles per hour. So that's really kind of small. But anyways, what we're looking for is this resultant vector. We're looking for A plus W, where A again represents the airplane and W represents the wind. So what we need to do is we need to figure out what A plus W is, because if we're going to find the speed, you can see that the magnitude is going to be the speed. So we can figure out the speed, that's going to be the magnitude of A plus W. And the direction is obviously going to be the distance from there to there. So we can just go ahead and figure out that vector and then find the angle of that vector. All right, so let's go ahead and write a vector, kind of like the last word problem for, or now what I was going to say is, let's go ahead and write an equation here for the vector of the airplane. So, all right, so we're at 55 degrees. Now again, your calculator does not understand 55 degrees as a bearing. It only understands this angle. So if that's 55 degrees, that means this has to be 35 degrees. All right. So your airplane has a vector of, so your vector, your magnitude is 220 times the vector of cosine of 35 degrees times the sine of 35 degrees. All right, and then the wind is going to have a vector, again, of our new angle, where now we're going to go in the negative direction. You could do the positive direction, but I think the negative direction is pretty easy. This is 90 plus another 10, so that's going to be a negative 100. So, and then this magnitude, this speed is 30 miles per hour. So I don't know why I put those. Let's just put 220. Yes, that is the magnitude, but you don't need to write. You can just put 220. And this one, you could just distribute that all the way through. That'd probably be easier to also understand. Like, just make sure you remember you can distribute that like I already kind of showed. All right, so the wind is at 30 miles per hour. And that's going to be times the cosine of negative 100 degrees, comma, the sine of negative 100 degrees. Okay, so now to find the resultant, if you remember, the resultant vector is basically the combination of your first components and your second components. So that's what I need to do. I need to figure out what A plus W is. Now, actually, I can store this, so that's fine. So I'm going to write this out just so you guys can see what I am doing. 35 degrees plus 30 cosine of negative 100 degrees, comma, this is going to be 220 sine of 35 degrees plus 30 sine of negative 100 degrees. Kind of squeezing that in. All right, so you can see basically all I'm doing is I'm taking the first two components, adding them up, taking the second two components, adding them up, and make sure that I also distributed those, okay? Now, I will write in the answer, but I'm actually going to store them as well. So I'll figure out the answer. So I'll do 220 times the cosine of 35, close the parenthesis, plus 30 times the cosine of negative 100, close the parenthesis. And what I'll do is I'll write in the vector rounded to the nearest hundredth. So I'll have 175.00. That's good. Now I'm just going to store this as A. Just to make sure that, because there was some decimals there, and who knows, it could make an impact here on further calculations. So then the next one is, so let's represent that as A. And also, it's just going to be easier to do that, and you never want to use rounded answers in further calculations. So let's go and do the other side, which is 220 times the sine of 35, close the parenthesis, plus 30 times the sine of negative 100. And that's, whoa, that doesn't seem, let me try that again. That seems weird. 220, no. Yeah, 220. So that seems about right. 220 times the sine of 35 plus 30 times the sine of negative 100. 96. Okay. I don't know what the heck I typed, but that seems better. So then this gives me 96.64. Okay, so, and then I am going to store that as B. All right, so you have your vector here, right? And does this make sense? Like, obviously, if we have a vector going, northeast and we have a little bit of wind pushing us back, we still should remain in the first quadrant, right? You guys would agree. Like, that should need to be in the first quadrant. Obviously, if I got like 2 negative numbers, like I did something wrong. To also give you some perspective, like when I first typed this in, I got like 3,000. I'm like, that just doesn't sound right. So now the next thing to do is to find the ground speed. So if I'm going to write the ground speed, all that is that's the magnitude of A plus W. So all I'm going to need to do here is to find the magnitude is I'm just going to do A squared plus B squared, because then I don't need to retype those digits. So I'm just going to do the square root of stored A. Oops. Stored A. What's happening here? Oh, that's it. The square root of A squared plus B squared. And I get 199, which makes sense, right? Because, obviously if you have wind going against the airplane, it's going to go slower, right? Unless they're counteracting that, it's going to be slower. So I'm just going to say 199.9 miles per hour. I didn't clarify what to round to, so I'm just going to round to the 10th here. Now to find the angle or the direction, I need to figure out what this angle is, and let's call this angle theta. Okay. Now, technically, since everything is in bearings, we're going to want to give the angle in bearings. But let's go ahead and figure out what theta is first. So that is going to be the angle of a vector is going to be the tangent of theta is equal to the second component over A. And again, I'm still having students that still struggle with this. Just make sure, remember, just solve for theta is the tan inverse of B over A. All right. So since I already stored A and B, that's the nice thing about this. I can just use tan inverse, and then I can just do B divided by A. And I get 28.9 degrees. Round to the nearest whole is going to be 29 degrees. Okay, but that's what this is. So that angle is 29 degrees, which is fine. But if we're going to talk about the direction, we're going to want to typically talk about that as a bearing. So we just say a bearing of, and obviously from here to here is 29, then we want to figure out it in from north direction. So that's going to be, 90 minus 29, which is 61. So a bearing of 61 degrees. Or you could also do north 61 degrees east. Okay, so 2 different ways for you guys to go ahead and do that. All right, that took me a lot longer than I thought, but yeah, I mean, it's kind of typical. It usually takes me like 30 minutes to kind of do the first page. So then hopefully I'll try to knock out these problems here rather quickly for you guys. So then I can maybe kind of see if there's any questions you guys have for on there. So I don't know why. Oh, geez. Okay. Is he a teacher? Yes, I am a teacher. My guys, yes, I am teaching. This is one of my things I decided to do this year for my students and for all of you that watch my channel, that I just kind of do the live streams for my homework as well as for my quizzes. So I'm hoping that, next year I'll be able to build upon this as well, change up the homework assignments. I'm not sure if I'm going to do live for this class. Maybe I will, maybe I won't. I don't know. But it's something I definitely enjoy for those of you guys. Just let you guys know, I'm just going to kind of go through, see if there is anything. If you could help me on my homework I'm doing. Oh, yeah. Yeah, if you can just send me any kind of problem that you have. I can try to do my best for you. And, all right, I think I have everything I need. All right, nobody has any question on things, so let me go ahead and work on this. Let me go and knock out the multiple choice problems real quick, and then obviously if you guys have a If you guys have any questions or you want me to cover any problems in your own classes, then go ahead and let me know. Isaiah, does not seem very nice. I'm not really sure. Oh, you're just joking. That's okay. I still see it. Even though nobody else sees it, I still see it. But that's okay. Zarif, shout out. Absolutely my man. You got it. Look forward to, let's get over this. I don't know why I'm rambling on. All right, so the next one says, write a vector in terms of I and j whose magnitude, v, and direction, theta, are given. So the magnitude is 7, and the angle is 225 degrees. Now, obviously, this is an I and j, right? So I can write this in the magnitude form of 7 times, actually, let's just distribute that 7. Actually, do it one by one. So let's do 7 times the cosine of 225 degrees times the sine of 225 degrees. Now, let's go to the unit circle. Where is 225 degrees? Well, here is 180, right? Here's 270. So 225 degrees is 45 degrees more than 180. Right? So if we were thinking like there on the unit circle. Well, that means it has a reference angle of 45 degrees. And if that has a reference angle of 45 degrees, we know the reference angle over here of 45 degrees. Again, I'm like going off of the unit circle. That's a horrible unit circle, but remember this point is square root of 2 over 2, comma square root of 2 over 2. So if this angle has the same reference angle of 45 degrees, but it's in the third quadrant, then we know this is going to be a negative square root of 2 over 2, comma negative square root of 2 over 2. So I can easily knock out any answers that are not negative in both, which is B. Okay, so B is definitely not the answer. Now I can distribute this. So I can distribute the 7. So this is basically 7 times the square root. Oh, oops. Yeah, so it's now going to be a negative 7 square root of 2 over 2, comma, negative 7 square root of 2 over 2. And then the only one here that would be the same, so that would be my vector in component form. And then if I just want to write them in terms of i's and j's, I basically just take the I and j there, and you can see that C would be your answer. The next one is find the unit vector that has the same direction as v. So basically, if we talked about this when we're looking at a vector, like here's a vector. When we reduce it down to a unit vector, like it has the same direction. So that's just saying like the direction is the same, but the magnitude is not obviously the same. So to do this, we obviously need to be able to figure out what is the magnitude of v. So the magnitude of v is going to be 5 squared plus 12 squared, or negative 12 squared. Okay, hopefully you understand this is a Pythagorean triple. If you don't, then I guess we could do it for you. 25 plus 144. And that's going to give you 169, which is 13. So therefore, my unit vector is basically going to be 5 divided by 13i minus 12 divided by 13j. Because again, you're just taking your vector and dividing it by its magnitude, right? So you can distribute that across. So that's a negative. So it looks like B is the answer here. All right, number 3 says find the magnitude of u plus v. So this one's kind of interesting. They're going back to, again, these are vectors. If you don't like these vectors, you can put in I and j. You can just put them as component form if you want to, 4, 1, right? And then apply the operations that way. But this one saying is add them first and then go ahead and find the magnitude. Kind of interesting problem. So let's go and figure out what u plus v is first. So that's, I'm just going to add those two components, which is going to give me a 0 plus 2. And then if I want to find the magnitude of that, the magnitude of this is just going to be the square root of 0 squared plus 2 squared, so which is equal to the square root of 4, which is equal to 2. And there you go. And then the last one is one that we didn't really cover as much, but it's basically finding the angle between two vectors. And there is a formula for this, which you need to use your calculator, typically. So cosine of theta is the dot product of u dot v all over the magnitude of u times the magnitude of v. Now that's actually a product. This is using the dot product. So we have our vectors. So let's go ahead and figure out what the dot product is. If you remember, we kind of worked on this on the free response questions. So that is basically your first two components multiplied, add times your second two components. All right, so therefore I get a negative 8 minus 30. So that's a negative 38. And then basically now I need to be able to figure out the magnitude. So in this one, it looks like magnitude is going to be the square root of negative 2 squared plus 5 squared. So that's going to be the square root of 29. And then let's figure out the magnitude of v. That's going to be the square root of 4 squared plus negative 6 squared. Now be careful, I'm not using parentheses. I'm going to put the parentheses back in there so students are careful. So 4 squared is 16, 6 squared is 36, so that's going to be the square root of, let's say, 16 and 36, so 52. All right, so really what I have now is the cosine of theta is equal to negative 38 divided by the square root of 29 times the square root of 52. Or I could say theta is equal to cosine inverse of all of this stuff, negative 38 divided by the square root of 29 times the square root of 52. So typically the way that I would write this in my calculator is I would do on, so I would just do negative 38 divided by the product, so I'm going to put that in parentheses, the square root of 29, close a parenthesis, and then times the square root of 52, close a parenthesis, and then close a parenthesis for the denominator. And that gives me a negative 0.97, and then I'll just do the cosine inverse of that last answer. And that gives me 168 degrees. Now, we can kind of like check this. If I round that to the nearest whole, like, does that make sense? As 68.1, right? This is round to the nearest degree. Okay, so obviously you can see that answer. But again, like, let's just make sure, of course, did I make a mistake, right? Or anything like that. Let's graph this real quick. So let's graph u. So that's going to be negative 2, 5. 1, 2, 3, 4, 5. All right, so that's u. And then v is 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It looks like 180, right? But obviously my scaling is kind of off, so I guess that would probably be like down there. But you can see like that's pretty close to like 180, right? So that makes sense. And it obviously the only other option there could have been like 178, would have been a pretty close one too. But assuming I typed everything into my calculator, I'm going to roll with 168. So there you go, ladies and gentlemen. That is your homework for the dot product on vectors. Hopefully that helped out. Now, if there's anybody else in here, anything, I'll be happy to kind of answer any questions that you guys have. So I'll spend a little minute here just kind of going through the chat and see if you guys have any questions. I'll be more than happy to kind of answer them for you. So open Q&A. All right, can you quickly go over ground speed on number 4 again? What was that? The Pythagorean theorem. Yeah, so I don't know who. Yeah, so Crystal, basically, like, don't really worry about the word like ground speed. Like, basically, you know, you're just looking for like the ground speed is like you're looking up there. So if you're looking at an airplane, like that plane is being affected by the wind, right? Now, obviously, unless they're like applying the throttle to like counteract the wind, they're going to be going slower. So the ground speed is basically just asking what is the speed of the plane with like being observed from the wind acting on it. And yes, basically if you look at this, like here's my vector, like for any vector, you just create a right triangle, and that's basically how we're finding the magnitude. Now, the magnitude, again, is the length of the vector. So, yeah, basically what we're doing is the Pythagorean theorem from on there. And ground speed is basically, again, just it's a technical definition we're using, but basically anytime we're looking at this, we're looking for that resultant vector. That is that red vector. What is happening with the plane when it's being impacted by the wind? So hopefully that kind of clarifies it a little bit more for you. All right. Going to bed. Hey, two-step equations. Give me two-step equations. Be happy to do it. Ian, Trig's kicking my butt. I definitely feel you. I like trig, but I know a lot of students, mine also struggled with the trig. It's, it's something that you're not used to. It's a little bit different, and, you got to get kind of used to it. So, Jeff says, what's up, big boy Brian? I'm doing very well, Jeff. Hope you're doing all right, too. Can you do number 3? What is it all about? I don't know what you mean, number 3. Does that mean the word problem or the multiple choice? What are you referring to Zarif? I'm not sure. So, does anybody have any questions? Ian says, I got a test on graphing polynomials tomorrow, and I was watching your videos without a calculator because that's exactly what I'm going to do. Well, very good. That's, there's a lot of different ways you can do the graphing polynomials. Main important thing with polynomials is making sure you understand zeros, plotting those x-intercepts, and then plotting multiplicity and end behavior. So if you're comfortable with end behavior and you're comfortable with multiplicity, obviously I don't know what you've been covering in class as far as doing it in, intercept method or actually like as a polynomial and having to factor it down. There's a couple different ways, and you can obviously get more technical or more difficult problems from there. But, obviously understanding multiplicity and behavior is going to be very important from that. The word problem. Okay. Yes, but I'm not sure what you want me to talk about on number 3 about the word problem. What was it you asked? I'm not sure. I'm not sure what your question was again. Number 5, do number. Well, I'm not going to do number 5. I don't understand the word problem. I'm sorry, I'm not really understanding what your question is. Akshay just finished up your videos. You're the best. Thank you very much. You're very welcome. Who is that about? Who asked that? Euro says, I'm taking Algebra 2 trig freshman year. Is that good? Of course that's good, right? I mean, everybody's at their same pace. I don't think there's, I don't think there is, any rush to get through mathematics for you. So, if that's what you're comfortable with and you're feeling good with and you understand the material, then awesome. That is very good. And I would just say keep on working, keep on, keep on challenging yourself. Don't compare yourself to others because there's always going to be somebody that's always like in a faster math class or whatever else. But just keep on working hard. But so far as understanding the math, as long as you're doing well, that's a very good job. Zarif, I'm not sure which word problem you're referring to. Number 4, if you have a specific question, I'll be more than happy to maybe elaborate on something that I was talking about. Obviously you can see I spent a lot of time through the problem, and also, just to let you guys know also, this is homework. So this isn't I'm not teaching this from a point where let me reteach the topic like I did in class today. I spent all day today teaching this stuff. We did a problem like this. So I went slow with my students, explain it. So if you're not understanding this and this is the first time you're learning this stuff, I totally get it, right? It is a complicated, type of problem, something, especially if you're not used to, you might not attach. But please understand the reason why I'm teaching it a little bit this way is because my students have already been exposed to this. So that's why, I might skip over some things or not show some steps. So, I do apologize for that if obviously you're looking for a more introductory video on that. I do have some more, kind of explaining it more step by step in my classroom videos. But for the homework, I just want to make sure I can give them some answers for them to check their work. But I would say, Zarif, any word problem, here's the main thing you need to do. So draw the problem, create the vector, create the equation. This is basically for like all word problems on vectors. Draw the situation, draw the vectors, create the equations. Now, once you've created the equations, you got to understand what the problem is asking. This one's asking for the ground speed, which is basically the resultant speed of the airplane, as well as the direction. So once I knew that, I knew I needed to figure out the resultant vector of the airplane plus the wind. And to do that, I added the two vectors together. I found their magnitude by using the formula, and then I found their direction, again, using the formula, but I used the direction as a bearing, not in standard form. So hopefully that helps elaborate a little bit for you. Or hopefully at least that helped out, because it is a difficult problem. Trust me. I even explained it step by step for my students, and I guarantee there's a whole bunch of them that still are going to struggle with this, looking at it over the homework or when we have a quiz or a test, any type like that. It's difficult. It's not something that come natural to a lot of students. We don't go through a lot of these problems every single day, so they got to learn how to work through them. So hopefully that helped. And Crystal, I'm really happy to hear that these helped. I was actually looking, kind of funny story. I'm going to get off the stream here a little, but I was, but yeah, so not really funny story. I'll skip off that. Maybe I'll save it for later. But yeah, so I'll be doing the live streams, guys, till the end of at least the end of the school year, and then obviously as we get into exam season, I'll start doing some of those as well for you guys. So hopefully it helped. For those of you guys that are following along with trig or precalculus. I don't try to cover everything in these homework videos, but hopefully for those of you that, are kind of covering some of these same issues or are about to, these videos are up there for you. So hopefully they helped. So, all right, guys, I will be back next week. So I hope you guys have a great weekend. And again, if you have any questions, feel free to look on the YouTube membership or on my, Facebook, reach out to me, and I'll be happy to get them on the next stream. So I hope you guys have a great night.